before we can talk about this, we need to review some of the basic things that we have. So I want to talk about these 8 topics about the electronic structure of the surface. So first of all, I want to classify. Again, I use the same approach. We just talk about material, bulk material first, and then I'll move on to surface-related property, particularly with reference to the electronic structure. Okay, so I want to classify bulk material by their properties. So in this case, the electrical property, particular resistivity, and so forth, and the type of material that we're dealing with, insulator, semiconductor, metals, right? And then I want to give you a very general description of band gap and band structure. Some of you may already know this, but some may not, so I'm going to give a very qualitative consideration of these idea using simple MO theory. I assume everyone would have the idea of MO theory from first year chemistry. And then I'd like to tell you a little bit about some physics which involve particle in a box. If you don't know particle in a box, I would do not worry too much about it. I just want to give a little bit of mathematical background that all of these general descriptions proposed by the chemists have a basis, mathematical basis, and indeed quantum mechanical basis, using the idea of particle in the box. Those of you who have not taken quantum chemistry may not know this, but I would not go into great detail. I would just tell you about some of the features of the solution related to particle in the box, how we use it in terms of band gap and band energy. And then I'd like to introduce then about periodic potential and the concept of Bloch function, because as you are from the first from module 2 about physical structure, you have the hallmark of a crystal is of course periodicity, right? Physical location of different atoms. So how do you describe physical location of atoms? So how do you describe translation symmetry with these atoms? And this is known as periodic potential, and the wave function associated with this periodic potential is known as the Bloch functions. And finally then, from all these, we can then generate the concept of band gap and band structure, the energy band structure, which is fundamental to bulk material. And I added 3 topics specifically related to services, the concept of service state, right? What is service state? How is this important? Service state is very important because this is what distinguishes nanomaterial from bulk material, because there's large amount of surfaces, and therefore there are large amount of surface states, and surface state will enable chemistry and give you interesting property because of this origin of the surface states. And then you will have transition between these surface states. You can do something with this surface state. You know, you can make from one state to another, and then create optical properties or electronic properties associated with transition between these. And finally, some surface-related phenomena. Okay, so these are the 8 topics I want to sort of define first, and then we go over, and hopefully we can have a handle on at least qualitative understanding of the surfaces, and therefore nano-object, because nano-object is in fact surface science, right? It's surface science. Okay, so first off, a way to classify bulk material, right? How do you classify bulk material in a general way? A common way, you just measure its physical property. And what a classic physical property is the resistivity. How resistant, how much resistant, or how conducting is another way of saying it, for a piece of material that you have in your hand, for example. Okay, so electrical resistivity for pure metal, right, can have a big range. You can be as low as 10 to the minus 10 ohm per centimeter. Usually is unit of ohm centimeter, right? Written as ohm centimeter like this in literature. At 1K, so you have to define what temperature, because whenever you talk about resistivity, because the resistivity depends on the temperature. Whereas a good insulator, the resistivity of a good insulator could be very high, because an insulator means that it's extremely resistive. So you have 10 to 22nd ohm centimeter at the other extreme. So this physical property, right, resistivity itself, is 10 to the 32nd, 32, right? It changes, right, in nature, resistivity changes 10 to the 32, order of magnitude, right, is huge, right? This range of property is huge. Is one of the widest range of any physical property you found in solid, right? So it's impressive, right? This resistivity. This is why everybody in the electrical engineer are very interested in this, right? Certainly about how resistive certain material is. And here's a table that I got from Physics Solid State. You can get it from any solid state physics book, which lists. This is from Cattell. It lists the resistivity, the bottom number. I think, yeah, bottom number and the top number lists the conductivity, which is 1 over the resistivity. Okay, and the scale is that this is the top one should be multiplied 10 to the 5th, and the bottom one is so this is in conductivity, and this one is 10 to the minus 6 ohm centimeters for the resistivity measurements. Okay, and one thing that that you notice right away, right, why we use copper wire for wiring up our house is because look at the conductivity of copper. It is among the highest. It's the second highest, right? The only other higher conducting material is silver. This row, right, the noble metal row, you have copper, silver, and gold. You have 5.8, 5.9 for copper, 6.2 for silver, and 4.6 for gold, right? All of them are very good, and copper in particular. Copper, people use copper because it's highly conducting, it's second conducting, highest conducting material, and it's cheap, right? You could have used silver if silver is cheaper than gold, but silver is not cheaper than gold, so people go for copper. So that's why we have copper wire in our house, is because it's a highly conducting material. Okay, I'll come back to talk about this next week. And remember, you have an assignment that you can download from the web on this. Okay?